Hi, the cfsvision project is proud to release an open-source, free-of-charge APB e-verification component. Some of the most important features of this eVC are full control over the APB transfer, APB protocol checkers, easy-to-use application programming interface, APB protocol functional coverage collection, fully compatible with AMBA 3 APB protocol version 1.0, and finally, complete sequence library for master and slave usage. Next, an overall architecture and usage example will be presented. One can find on the bottom of the screen in the blue bar the related code during presentation. The entire eVC stays in an APB environment. Inside this, it can be found an environment configuration unit from which the number and aspect of the agents can be configured. There are three types of agent lists depending on the aspect: a passive agent list, an active master agent list, and an active slave agent list. Let's say that one wants an APB environment with only one active master agent. For this, the number of passive agents must be constrained to 0. The same constraint has to be applied to the number of active slave agents. Finally, the number of active master agents must be constrained to 1. The agent has a typical architecture. One can find inside an agent configuration unit to control the agent, a signal map unit to interact with the DUT, a monitor, a bus functional model unit, a driver, and a synchronizer, for which the main purpose is to emit basic clock and reset related events and to handle the entire agent at reset. There are several steps that must be taken in order to be able to use the eVC. First step is to connect the ports from the signal map unit. For monitoring, it must be declared somewhere in the verification environment a method port for receiving items from the monitor. Next, the body of the method port must be declared. Finally, the receiving port from the verification environment should be connected with the transmitting port from the monitor. For driving, one must declare in the test a sequence from sequence library. In the example below, master transfer sequence is used. Finally, declared sequence must be called. This will automatically send it to the driver, then to BFM, and finally, via signal map unit, will reach the DUT. The eVC comes with an example in which are available tests for running the most commonly used scenarios. These tests are basic read-write transfers, back-to-back read-write transfers, multiple reset during APB transfer, transferred with no extra cycles during the wait state, custom data pattern for read and write transfers, random read transfers, random write transfers. The demo simulation script supports running simulations in both Model Sim and NC Sim simulators. The simulation can be invoked in batch or in interactive mode. There is also the possibility for running individual tests or running regressions using vManager. All the available options for demo scripts are available from Help option. You can download this eVC free of charge from our website www.cfs-vision.com. You can send feedback and ask for support using email contact@cfs-vision.com. Thank you.